langsung. Tumpah. Itu dia kena berapa? Tahu. Dia kena sama.
So this is the disc brake. At first we have divided it into six parts, 1, 2, 3, 4, 5, 6, and then we have to take this vernier caliper and measure the thickness of these 6 parts. We have find out that the 6 parts have the same thickness and is in good condition. This is the brake caliper. As you can see, there is a piston inside, so later on we have to remove the piston. And this is the rolling pin. So this is the another side of the brake caliper, and as you can see, there is 2 brake pads, and later on we have to remove this brake pad and check the surface of it. As you can see, this is the brake pad, and we have taken out from the brake caliper just now, and we have to measure the surface and the thickness of the brake pad, and we have found out that the brake pad and the thickness is in good condition.
Greetings everyone, my name is N.HAVINESH and my matrix number is B0920103994, and I'll be explaining on the outcome. So for the first outcome is labeling the brake caliper, the parts of the brake caliper. As you can see, this is the picture of the brake caliper, and there are numbering labeled on it, and each number represents its parts name. So for number 1, it is the guide pin. Number 2, it's the lock pin. Number 3, there is nut, then pad, dashboard, piston seal, and number 7, it is also called as dashboard. Number 8, piston, boot ring, cylinder body. Number 11 and 12, there are brake pads. Number 13, there is shim, and the last one, number 14, it's brake mounting clip. So these are all the parts that can be found in the brake caliper. So next is the table 2, which is to inspect on the condition of the disc brake. So for the wear indicator, it is in a good condition. For the disc brake surface, it is in a smooth surface. This is because when we inspect the disc brake surface, we recorded the diameters for all segments, and we have found out that all segments have approximately the same reading. So that is why we predicted that the disc brake, it is in a good and smooth surface. So for the outboard brake shoe pad, it has a good condition and has a thickness of 7.0 mm. For the inboard brake shoe pad, it is in a good condition and has a thickness of 6.70 mm. For the piston, we find out that the piston doesn't get stuck when we use the air compressor to push it out. So it means that the piston is working well. And lastly is the cylinder bore. It has a smooth surface and doesn't contain any scratches on it. So next is table 3, where we inspect the disc brake measurements and condition. So first is the run out measurement. We didn't get to carry out the run out measurement because we don't have the proper tools and equipments. Thus we proceed with the disc measurement. We have done 6 average reading of the disc brake measurements, and the average thickness of the disc brake is 8.43 mm. So number 3 is the rub test. We have found out that all the surface of the disc is in contact with the brake pads. And number 4 is the guide pin and lock pin straighteners, and we have found out that it is in a good condition and makes a perfect round when it is rolled on the floor. So next is the discussion. So first is the findings on the condition of the brake pad and should it be replaced with a new pad. So based on our finding, we have found out that the brake pad is in a good condition and all the surface was smooth and in contact. Thus, it is not necessary to change with a new brake pad. The average thickness of the brake pad that we measured was 8.6 mm, which is acceptable and doesn't need to be replaced. This is because the actual thickness of the brake pad should be between 8 to 12 mm. Next is the 2 causes of rotor thickness variation. 2 causes that can lead to rotor thickness variation are lateral runout and scoring on the surface of the disc brake rotor. Lateral runout is caused when there is an uneven torque being applied on a brake stud. However, the most common cause of lateral runout is rust building up on the hub assembly. Hubs are often in use on a vehicle for hundreds of thousands of miles. As you can imagine, a significant amount of rust will build up on the hub over that period of time. For the brake disc scoring, it is usually caused by several reasons, including overusage of brake pads, poor disc brake material, and contaminated pads being fixed. This can cause the brake disc to worn out, and the thickness of the disc brake might vary as time goes by. As a result, it might reduce its efficiency when braking is applied. So next is the repair procedure for the thickness variation. So the thickness variation that we mentioned is the lateral runout. So the procedure is, first we need to clean the hub and then install the rotor and conical washers. Number 3, we need to install the dial indicator, which is known as the TTI gauge, to check the fitting of the brake disc into the hub. And lastly, check lateral runout by spinning the rotor, and the specifications can be found in a specification guide or the vehicle's service manual. Next is the understand about runout measurement. Runout measurement data is basically the process done to check if the brake disc is in alignment. The maximum amount of tolerance for brake disc to be run out should be more than 0.08 mm. What is your finding for the guide pin and lock pin straighteners check? What can happen to your disc brake system if the guide pin and lock pin is not straight? So, as you can see, we have carried out the straighteners check by rolling the pins on the ground. As a result, we have found out that the pins makes a perfect circle, which indicates that the pins are in good conditions and doesn't need to be replaced. If the guide pin and lock pins are not straight, grinding noises can be heard when driving and causes difficulties when braking. This is because the calipers will not be meeting the rotor at the proper angle. Thank you.